Good evening, my dear students from 10th grade students. Well, welcome to the first unit of physics. In this case, we're going to talking about according for the kinematics. The kinematics is a part of the physics that study the description of the motion. Well, in this unit, we're going to talking about according for the definition of the kinematics, and going to study the first two actually the three kinds of motions. All right. Well, first of all, we have to establish what does that mean to kinematics. The physics and the mechanic of the physics is we can divide it in two ways: kinematics and dynamics. The kinematics establish the description of the motion, and the dynamics explain why the motion. Okay, but in this unit, we're going to focus only in the description of motion. Well, in this situation, the description of motion, we have three kind of them. The first one is the motion horizontal path. The second one is vertical path, and the third one is dimensional path. I mean, the bidimensional path. Another way of saying is the parabola movement or projectile path of projectiles, as a matter of speaking. In that movement, we're going to create horizontal or vertical path at the same time. Okay, so let's going to start with the motion in one dimension. In this case, we're going to establish what will be the difference between uniform speed and velocity and acceleration. Well, first of all, before talking about the uniform acceleration, we want to establish the difference between distance and the difference between displacement. And so same happen with speed and velocity. But before to do that, we must define what will be the difference between a scalar and a vector. Okay. Well, actually, scalar and vector are quantities who has measure both, but the difference between them is in the scalar, the direction, it doesn't matter the sense of the direction, but by the other hand, the vectors, the direction does matter. Example for the scalar, example of the scalar could be the distance, could be the speed, could be the mass of any objects, the period of time, because we can obtain measure, but we cannot determine the direction. This is by one hand. By the other hand, the vectors could be the displacement. The displacement is the change of position for any particular body from one point to another one. That means when we said that object moves 10 meters from its, for that we're saying in one singular way, it's moving to the right side. And if you said it's returning 10 meters to the west, so because the displacement, the change of position, the answer will be 0. Why? Because when you said return to east, the west, returning that is a displacement to the left side, and that will be a negative displacement. For that reason, if you add 10 minus 10, well, there's a subtraction, the final result will be 0. Okay, and same happens with the speed and velocity. What is the definition for speed? Is the displacement, the total distance, sorry, divided by the total period of time. And the velocity, the velocity or average velocity is the division between the displacement divided by the total period of time. But in this case, the uniform speed or velocity, we have one other single equation. D equals B times T, where D represents the distance of displacement, B represents speed of velocity, and T represents the period of time. Remember, we have two units in the international system and British system. The international system, the distance or displacement metering, we got the measuring meters, the velocity speed meters per second, and the unit of time will be seconds. By the other hand, British system, the distance or displacement, the unit will be feet, the speed or velocity feet per seconds, and the unit of time will be the same, seconds. But what does that mean, the word uniform? Uniform, that means the same rate, the constant. We're going to obtain the same speed or the same velocity in a period of time. For that reason, because we are not increasing or decreasing the velocity, the value of the acceleration will be 0. So simply merely words, there is no acceleration of the objects in that case. By the other hand, the acceleration is a vector who has magnitude and direction, and the acceleration can be defined by the change of the velocity. And for that reason, we have 4 equations as soon as you can see in the whiteboard. The first one is distance equals final velocity plus initial velocity divided by 2 multiplied by the period of time. The second equation, distance will be 1/2 acceleration times square plus initial velocity times period of time. Third equation, final velocity equals initial velocity plus acceleration period of time. And the fourth equation will be final velocity second power equals initial velocity plus 2 times acceleration and distance. Okay, obviously the uniform speed and uniform acceleration both are part in the motion, the one dimension, but one dimension that will be in the horizontal path. By the other hand, we had the freely falling objects. As soon as you can read in the whiteboard, in the freely falling objects, this is a vertical path movement. And the vertical acceleration in this kind of problems will be given by the gravity. The gravity is the acceleration who drags any object to the ground. And the gravity, for that reason, is a vector because it's moving to the ground. Always we're going to have a negative value. What is the constant value for the gravity? That will be 9.8 meters per second square in the international system and 32 feet per second squared in the British system. In the freely falling objects, we must consider some kind of keywords, little details that makes big difference. Well, those details, my dear students, can be given in one in how to say that in one singular concept. For example, this is not the same thing when we're talking about when you grab an object. I don't know, could be a stone, could be a marker, could be a ball, and whatever you want, and drops upward. Well, you throw it upward, right? Because the height and the accelerator and the velocity, both are vectors, it has magnitude and direction. Because both elements moves upward, the higher the velocity will be considered positive because we're following the signs of the coordinate plane. The y-axis represents the behavior on the height. When moves upward, it reaches the positive y-axis. When you have the same objects and you drop the object or moves or throws downward, the height of the velocity will be negative values. There's another consideration. When any object reaches the maximum height, the final vertical velocity will be 0. Why? Because there's an air resistance force that will be decreasing the speed of the velocity of the object when it moves upward. Okay. And the time of the period of time, just in case when you drop an object upward, it moves downward and they're moving the same height, well, the upward period of time, that will be the same period downward of time, just in case the object moves at the same height. And if you really want to know what will be the total period of flight, the only thing that you have to do is multiply that period of time by 2. For example, if the object reaches the maximum height in 5 seconds, and the returning time also will be 5 seconds. If this is moving from the and landing from the same starting point, okay? For that reason, the total period of time will be given by 10 seconds. Well, we're going to obtain 3 kind of videos. Today, we're going to establish the first video trying to solving problems for uniform speed or velocity problems. All right. Tomorrow we got wheels. We're going to the solving three problems that involving uniform acceleration. And if we got wheels the same day, we're going to solving three problems to remarkable freely falling objects. Okay. Remember, if you have doubts or questions, please write me in the comments. Okay. And if you like the video and you enjoy it, please give it a like and give it a like, subscribe, and share the video. Okay. Well, let's going to begin with the problems. Okay. We have three problems, and it's going to solving one by one. Okay. In the first problem, the first situation, let me approach the camera a little bit over here. So as soon as you can read perfectly well, okay? Remember the three problems we're going to consider only, again, two or one singular formula, D equals B times C, okay? Because D represents displacement or distance, B represents velocity or speed, and T a period of time. But we must to be careful at the moment to apply the concepts, because even though we have one singular equation, but if you don't have any idea of the description, the concepts, what is the average speed versus absolute velocity, it's easy to get confused with the problems. Okay, so let's going to start with the problem number one. The problem number one says, okay, we have a hospital nurse that walks 25 meters to a patient's room at the end of the hall in 0.5 minutes, period. She talks with the patient for 4 minutes and goes back to the nursing station at the same rate that she came. Okay, so when the problem says at the same rate that she came, she returns 25 meters for 0.5 is 25 meters and 0 meters in 0.5 minutes. 25 meters in 0.5 minutes, okay? So we have the question, what was the average speed of the nurse? Okay, so basically, we have to establish the constants. For example, what is the constant for the average speed? The constant of the average speed is the total the total distance divided by the total period of time that's happened in one single situation. Okay, so if we analyze the situation at the moment we want to create the data of the problem, remember that the data of the problem says that's going to define the total distance. The total distance in this case, remember, the first track, the nurse moves 25 meters. And the problem mentioned he goes back to the nursing station at the same rate she came. What does that mean? She moves 25 meters at the beginning and returning 25 meters. So that reason, the total distance the nurse moving will be 50 meters. Okay, that will be the first value for distance. Now, if you ask me, okay, but just in case the problem asking for what will be the average velocity, remember the average velocity, that's supposed to be the division between the total displacement divided by the total period of time. If we said he's moving 25 meters and he's returning 25 meters, the displacement will be zero because there is no change of position. And you can subtract, okay, the first track to the right side, 25 meters positive, and the second track will be negative 25 meters. So 25 minus 25, that will be zero. For that reason, there's no sense to apply the equation from the uniform velocity because the displacement is zero divided by time, that will be zero. But in the average, and this is the average speed, remember, is the distance. It doesn't matter the direction, that matters the magnitude. Now let's see what happened with the total period of time. Remember, in the first track, 0.5 minutes. And the second track, remember, this is the nursing station. She came, she goes back the nursing station at the same rate. What does that mean? The second time will be 0.5 minutes also. That will be 1 minute, okay? And we have to add the 4 minutes that she's talking with the patient because the problem never defines, okay, I'm going to consider only the movement time. The problem always consider the total period of time. For that reason, if you add 0.5 minutes, sorry, from the first track, plus 0.5 minutes for the second track, plus the 4.0 minutes that the nurse is talking with the patient, we can conclude that total period of time will be 5 minutes. So we have to looking for what will be the average speed, okay? But remember, 5 minutes, we must transform the 5 minutes into seconds. Remember, 1 minute has 60 seconds. So that is 5 times 60. The answer will be 300 seconds. Okay, 300 seconds. And because we know what we have to do, remember the formula from distance will be given by d equals b times t. And if we're solving this equation by b, d divided by t will be the velocity. Well, the distance will be 50 meters. Okay, and the total period of time will be 300 seconds. For that reason, the average speed will given by 50 divided by 300. The answer will be 0.17 meters per second. This is going to be the average speed. And again, if you ask me, okay, mister, and if the problem asking again, what will be the average velocity? That displacement instead to be 50 meters, that will be 0 because 25 minus 25 is 0. 0 divided by 300 seconds, the answer will be 300. And this is going to be the solution set from the first problem. Okay, now let's going to analyze the second situation. In this problem, we're going to clarify what will be the difference between average speed and velocity. Well, if you read the problem mentioned, okay, we have an exit crawls along the edge of the rectangular swimming pool of length 20 meters and width 21 meters. We have the picture, okay, the problem. If crawls from the corner A to corner B, we have two questions. In 30 minutes, the question is, what is the average speed and what will be the average velocity? Okay, let's going to analyze the data from the average speed. Okay, the average speed. Remember, average speed will be the division between, just in the first problem, this total distance divided by the product period of time. What will be the total distance? Well, simple distance. It doesn't matter. That matters the magnitude, not the direction. When I say the magnitude, I'm talking about the measure between the length and width. So if you add 21 plus 27, that will be 28 meters. It doesn't matter if this is a vertical position, this is going to be horizontal position. And the period of time, the problem says, okay, it takes around 30 minutes. Remember 30 minutes, remember 60 seconds, we have a 1 minute. So 6 times 3 will be 18. So 1,800 seconds will be the period of time, okay? So they're asking for what will be the value from the average speed, okay? So because remember, you must multiply 30 times 60 and the answer will be 1,800. Well, let's calculate the average speed. B equals D over T. I mean, the distance will be 48 minutes divided by 1,800 seconds. For that reason, this answer will be given by, just hold on a second, would be 48 divided by 1,800. So the answer will be 0.027. 0.027 meters per second. This is the solution from the average speed. Now, let's talking about with the average velocity. I'm going to write over here the average velocity. I'll do it in this way. Average velocity. And the average velocity, my dear students, is the displacement. What is the definition between the displacement? It's essentially the position between one point to another one. If you see the crawler, the insect crawler, that will at the beginning has a point 8, and at the end moves at this slant displacement between, sorry, I'm missing with my pulse, A until B, creating the shape of the right triangle. All right. In the displacement, you cannot adding horizontal distance and vertical distance like a algebraical process. For that reason, to determine what will be the displacement, we must apply the Pythagorean theorem. Remember, the Pythagorean theorem says C equals square root A squared plus B squared. So basically, in this case, instead to use C for the Pythagorean theorem, well, actually, I'm going to write the formula Pythagorean theorem just for remind you. C equals square root A squared plus B squared. Okay. Instead to write C, I'm going to replace C by D that represents the displacement. A represents the width. In this case will be 21 meters, second power, plus B represents 27 meters as the second power. So let's see what happened. 21 second power plus 27 second power. We can take in the square of this problem, and the answer for the displacement will be 34.21. Okay, 34.21 meters. This is going to be the value from the displacement. Okay. And finally is going to try to looking for what will be the value from the average velocity. Same happens, same formula. B equals D over T. You know, the displacement will be 34.21 meters because it reflects the change of position between A until B. Again, I'm going to write over here that will be 34.21 meters. This is going to be the displacement between the one point and another one. And this displacement must be divided by the same period of time. That will be 1,800 seconds. For that reason, the average velocity will be given by 31.21 divided by 1,800. So the answer will be 0.019. 0.019 meters per second. And this is going to be the solution set of the problem number 2. Okay, so we perfectly established the difference between the average speed and the average velocity. Now, let's going to read the third problem. Obviously, we require a little bit space. Let's going to analyze the situation. And after that, let's see what happened, okay? If we have some space, so we require to erase the wiper. Okay, the problem says, two runners approaches each other on a straight track. What does that mean? One runner moves to the left side and another one to the right side. Have a constant speed of 4.5 meters per second and 3.5 meters per second respectively when they are 100 meters apart. So what does that mean? That means, let me create a picture of the problem. We have the first one. We can assume this runner has has a velocity of 4.5 meters per second. Okay, obviously, this runner moves to the right side over here. And the another one moves to the left side, okay, with a velocity of 3.5 meters per second. Left side. Okay. And the problem established that happened, both runners are separate initially at distance of 100 meters between them. Obviously, there's no possibility that run both of them that will meet because there are two questions. The first one, in how long will take for the runners to meet and what position will be they located. That's impossible. The way to determine both will be located 50 meters because the only way possible to do it in 50 meters is both have the same velocity but well, the same speed in this case, but that's not going to happen because one of them is faster than another one. So what in simplementary words, what is the meaning of this situation? The meaning of this situation is the person who's running faster, they're going to move or they're going to recording a little bit more distance than the second one that will be slower. Okay, and the period of time, the first person that will be smaller than the second period of time for the slower. It's a little bit complicated. Okay, just tell. Well, actually, because we have, even though we have greater speed, we're going to take greater distance. However, a smaller period of time. By the other hand, the smaller one to the slower one remove or recording a shorter distance than the first one, but in a little bit greater period of time. But what is the distance that these runners are moving? Because we have no idea what will be the distance. It's simple. We must create a distribution for them. We don't know what will be the distance this runner is moving. We're going to establish an x value. And another one will be the difference between 100 minus x because they're never overpasses the 100 centimeters that is separating at the beginning. This is a one picture that useful at the moment to create the problem. Okay, I'm going to erase the whiteboard. Well, actually, this part of the average velocity. Okay, and the second problem, because we copied that already. And if we require a little bit space, we can erase the rest of the whiteboard. Okay, so we have the required space. Well, uh, we have a singular situation. Okay, we are recording the distance. The first one again is moving in x distance, and the other one will be the difference between 100 meters minus x. Okay, so what do we have to do? in this situation? Well, remember the problem asking for what will be the period of time that will meet. So basically, we have to establish the system equations, okay? Just approaches so gave us one singular idea what we're talking about. Remember, x represents the distance that will be velocity times period of time for one of them. And another one that will be the difference between um, the both distances, a matter of speaking. Okay, so what will I tell you? We don't know exactly what will be the period of time, so we have to establish in how long they will be met and establish what could be the system of equations. Just hold on, we have some. Okay, where I'm saying, because the problem established in what period of time they will be met, that means the time for the first runner that's supposed to be equal the time of the second runner, even though uh, the runner you have to moving up the 100 meters, the period of time that will be different because the problem mentioned they will meet, we have to establish the period of time, the runner number one, T1, there will be the same period of time with the runner of the period number two. Remember at the moment when to establish the equation, distance will be velocity period of time. If we solve for t, d over b equals t. So let's going to replace that values. Distance 1 over velocity 1, that will be equal to distance 2 over velocity number 2. Okay, what is the value for the distance number 1? X. What is the value from the velocity number 1? 4.5 meters per second equals to what? Distance number 2, that will be this green part. I mean the difference between 100 meters minus x divided by the velocity number 2, that will be 3.5 meters per second. Okay, and we have the proportion. This 3.5 meters is multiplying, is divided, passes to multiply, and actually we can perfectly cancel the units meters per second with meters per second. And we got the proportion 3.5 over 4.5 x equals 100 meters minus x. Okay, because this 3.5 that's multiplying passes to, sorry, dividing passes to multiplying. You can divide 3.5 divided by 4.5. The answer will be 0.77777. Or if you wish, if you really want to write a fraction, that will be 7 over 9. However, you can use the decimal numbers if you wish. That will be equal to 100 meters minus x. Okay, so basically because this letter x is subtracting, passes to adding. And we have 79x plus x equals 100 meters. I mean 79 plus 1 will be 16 over 9x equals 100 meters. So if you really want to solve what will be the value from x, well, x will be equal 100 meters multiplied by 9 and divided by 16. And this is going to be the value from x at this, the first position. Well, 100 times 9 divided by 16, the answer will be 56.25 meters. 56.25 meters. That will be the position for the first runner. So if we really want to establish what will be the decision number one, remember the distance one, the runner number one is X. I mean 56.25 meters. Okay, this is the distance on the runner one. And the distance of the runner two, remember what the problem says, okay? We had the 100 meters minus the distance moving for the runner number one. So basically the distance number two will be given by 100 meters minus 56.25 meters. So the distance of the runner number two will be given by 43.75. 43.75 meters. We have the second position. Well, actually, we answered already the second question. At what position they will meet? They will meet if they maintain these speeds. Okay, the first runner 46.25 meters and the second one 43.75. And that's the first question is, okay, how long will it take for the runners to meet? Well, actually, we can use this equation. Let me erase this part of the equation, and let's establish over here what will be that formula. Remember, we established T equals distance divided by the velocity. It doesn't matter which one would you like to use at the moment to substitute the letter D. The answer will be the same. So let's use in the first runner. The distance, remember, is 56.25 meters. And we must divide it by the velocity. That will be 4.5 meters per second. Okay. For that reason, the period of time reaches for the first runner, okay, 56.25 divided by 4.5, that will be 12.5 seconds. That will be the period of time that will be met. But this is just in case you're doing for the first runner. But if you want to do it from the second runner, you shall see we're going to obtain the same result. Obviously, we have to use the second distance, 43.75 meters over the velocity of the second runner. That was 3.5 meters per second. And if you calculate the period of time, will be 43.75 divided by 3.5. So the answer will be 12.5 seconds. So this is an easier way how to check your answer, because this is what the problem means. At what period of time both runners, I'm going to erase this one and copy the general formula, okay, over here. T equals D over V. In what period of time they will meet. So we are proving the first runner. They're moving a distance of 56.25, moving at 4.5 meters per second, reaches of they'll meet the second player, a second runner in 12.5 seconds. And if you see the perspective for the second runner moves only 43.75 meters, moving at 3.5 meters per second, and they'll meet velocity of a period of time of 12.5 seconds. Okay, guys, it got wheels tomorrow. I'm going to continue solving another 3 problems, but this time involving problems of uniform acceleration. If you enjoyed the video, if the video was useful for you guys, remember this is the formulas. We watch the description of the problem, and we are solving 3 exercises. Well, thank you so much for your attendance. Have a great, wonderful day. Remember, if you enjoyed this video, if you push the like button, subscribe, and share the video. Have a nice and wonderful night. Take care of yourself. See you tomorrow in God wills.